Hello and welcome to This Old Junk. Welcome to Test Gear Tuesday. Today we're going to look at a newly acquired piece of test gear I got, and that is the device in front of you, and that is a GW Instek GSP-810. Without cheating, without looking, how many of you know what GW stands for? Put your comments down below. Let's see who's the brightest among us. Remember, no cheating, because cheating is it's like cheating. I've only had this spectrum analyzer for a few days, and I've been playing with it extensively, and I have really come to enjoy it and really like it. This is not a high-end unit by any means. It definitely does have limitations. I think at this point in time I'm okay with that. It's definitely a unit that will allow one to learn and grow as you grow. Now, up to this point, I have had this one. This is a tiny SA spectrum analyzer for those that are unfamiliar, and this little guy covers from 100 kilohertz all the way up to 960 megahertz. I've had this one for, at the time of filming, about 6 months, and truth be told, I haven't really had a chance to use it that much. I've played with it more than I've used it. I have just been extremely busy this year, and as some of you who are followers of my channel or I follow, my activity both on my channel and on your channel has been reduced. I've just been a lot of projects behind camera, a lot of other things happening that's kind of taken me away from YouTube and all my toys. And I'm okay with that. Back to the meat of the program. Here we go. The spectrum analyzer covers 150 kilohertz all the way up to 1000 megahertz. That is its specs. However, I have tested and it does go just a little bit below and just a little bit above. Going below, I believe I clocked it to go to about 86 kilohertz. And going above is 1150 megahertz, 1.150 gig, or just about there. It's close enough for government work. This device came out, I think, between 1999 through about 2015, 2016, somewhere in there. Since I have the device powered up and turned on, we're going to go ahead and check out the face panel first, its buttons, etc., etc. Then we'll do some sample testing, and then we will open it up and look at the guts. At which time, I want to see how easy it is to remove the carry handle, as mine is broke. The interlocks that lock between the handle and the case, all those little plastic tabs have broke off, and now it's looking like some kind of redneck with about 2 teeth in his mouth. So we're going to try to pull that off. And secondly, I want to see about adding a input for a 10 megahertz reference input. Here on the front panel we have our badging up here, GW Instek. By the way, did you find out what GW stands for? Congratulations if you did. Spectrum Analyzer GSP-810, 1000 megahertz. We have the CRT, yes, CRT. In the camera, this kind of looks like a blue display, but in person, this is more of a greenish blue display. Down below here, we have our intensity, which controls the brightness of the display. And honestly, I found just past halfway, there really is not much of a difference. We have a control here for our Y-axis. We have our focus control. We have a headphone jack. We have a volume control. We have a control here for our X position. And basically the Y position controls up and down. Our X position controls left to right. And then we have a physical hard power switch. We will come back to our volume and our headphone jack in just a moment. On this side of the device, we have our LCD display, which tells us our settings that we're configuring for the CRT. We have our frequency, and here we tell it where we want to go. Right now we're looking at 5.564 megahertz, and our resolution is only 3 digits to the right of the decimal point. We only have a megahertz designator. For frequencies below 1 megahertz, you have to use your 0.1 or 0.0 to achieve what it is you're after. At which time you have the option of hitting the megahertz button, or you could hit the enter button. We have our 10 key, which will achieve our frequency of desire. And we have our arrow keys here, which will change our pointer, because then we can come right down here to our control knob and control that digit only. We have our buttons here for, in the white, center, span, our reference level, marker, delta marker, memory, and real bandwidth. And then we have our shift key here in blue, which then operates our blue options, which would be demod, power meter, tracking generator, peak to marker, marker to center frequency, trace, and setup. This device has a in connector for a output jack. Currently I have a in to BNC adapter on here. This vacant port is where our tracking generator option would be. This device has 3 options: tracking generator, a power meter, and remote control. Now that's what is put in the book. Unfortunately, or fortunately, however you want to look at it, there actually is another option, and that is our demod. And again, we will come back to that in just a moment. Those of you who know what a demod is, don't get too far ahead of yourself, because that could be true. Looking at the menu on this is a really basic, really simple device. I had to consult the manual very infrequently just to figure out a few things. Like I said, I have the other one. I haven't played with it enough to know all of the verbiage and the lay of the land. So went to the manual, which is not very big. The manual's 35 pages big, and we will get to that in just a moment as well. To access the setup menu, it's real simple. You just push shift and then setup. That brings up this menu, at which time you see our signal reference is turned off. That's because in my last take I goofed it up, and this is take number 2. We will simply push this button and turn it on. By doing so, it takes a reference, I do believe, from our internal 10 megahertz reference. And then to access the other options, as you see here, we have a down arrow. You use your knob here and you turn it down till you get to your next option, and then to execute said option you push your arrow. And that's funny because we should have more words than that. That is the first time I have seen that do that. I'm wondering if it's because the reference was turned to off position, and no, it's not. Let's go ahead and turn this off real quick. This device at this point has been running, actually all my devices at this point have been running for about 5 to 6 hours warming up. And there you can see the boot up screen. That one had the date of 2001, so that's going to date this device more than likely to 2001. When we open this up, hopefully we'll be able to find some date codes to confirm, yes, that is said date. Let's go ahead and go into the setup menu. We'll push Shift Setup. We'll go down to Option Report. There we go. There are the rest of the words. And what this is telling us here, SW stands for software, so we have the revision 01.31, our firmware revision of 1.5. Tracking generator, no, we do not have that option installed. Our receiver installed, yes, and we'll come back to that in a moment. PM stands for power meter, and no, we do not have that installed. That would coincide with our tracking generator. And then here our reference, is it standard or extended? It is standard, and it's coming from our internal port or from within inside the device. Do that to get out. And then here we have test all, and it is locked. Unfortunately, you can do nothing about that. Just live with it. The manual does not really declare what locked means. Is that good or bad? I don't know. And when you continue on, you're going to see that we have LO1, 2, 3, and just 3. The LO stands for local oscillator, and again, the manual does not declare whether locked is good or bad. I would imagine locked is good, that everything's synced and the 10 meg reference is doing what it's supposed to, and all the magic voodoo that's happening inside is doing what it should. Now here's a quagmire for you. The power meter option, you can do dBm or milliwatts, and what that is declaring is for the tracking generator option. Why is that left available to play with? I don't know. It does nothing without that tracking generator. Our mark style, our option there is line or dot. In the screen, when we brought it up, you saw the really slender line. The dot, all that does is put a little tiny dot that's really hard to see, kind of looks like a pip on a FM stereo tracking generator. And now we'll back out of here because that is our last option. When you're presented with the screen powered on, it goes to its last placeholder. To access your markers, which we're not seeing here, actually let's go ahead and talk about what we're seeing here. We're seeing our center frequency, and that's what the center stands for, center frequency of 5.575 megahertz. We are at 0 dBm for our reference line level. Our span is 200 kilohertz, and our bandwidth, real bandwidth, is 30 kilohertz. Now, as I stated, this device is crippled, and I could see where that could be challenging if you're really needing to get down to the nitty and gritty, the finer details of things, because the options that we have in these two settings change depending on where you are in the spectrum. So here in the 5 megahertz spectrum, I think from about 1 meg on up to 500 megahertz or so, I really haven't tested the breakdown. These numbers change. And so to access our span, you push the span button, and now you can change what it is you want, as well as turning it off. And to change our RBW, we push our RBW button, and now you can change 220, 30K, 3000, and that's it. And again, depending where you're at, the options may or may not change on you. You lose or you gain. It's kind of hokey pokey. To bring up our markers, we simply push our shift correction. You push the marker button, and that brings up 2 more displays. And what we have here is it's telling us that our center frequency last measured was 5.564 megahertz, and currently it is reading a negative 73 dBm. Number 2 marker, we currently have either off, or our settings here don't make sense for that to work appropriately. So far in my testing, in my very limited, not testing, playing, I've been very happy with just running with the center marker. I'm sure later on in my testing, the second marker will come in handy, and we will demo that in this video as well. If you wanted to change the frequency here, instead of pushing a button and it finding it, you just simply push your arrow, and now you can change. And you see here, I went from 7 megahertz. It turned this marker off because it's too high. It just does not make sense. So we turn it back down, where in our settings it does make sense. So now we can change here, and I know you're not seeing it because we're tight on that screen. The marker is moving. And if you wanted the other 2 digits, you just do that as well. If you wanted to change marker 2, you could either push this button back out to 2, then turn your knob down, takes you to number 2, and then you just roll on over there, and same thing above, you just turn it on. Other option is simply push your enter button, and it takes you down to line number 2, and then you now control line number 2. If you wanted delta markers, you just simply push your delta marker, and what it does, you see this triangle symbol, it puts that triangle symbol up there. And from reading the manual, what it says is it takes the difference between marker 1 and marker 2 and displays that difference. And here in this shot, you can see the marker here on screen. And as I change, you can see said marker moving right along. And for marker 2 to come on screen, there we go. And now you see marker 2. Now, as you see on screen, our marker trace is really slender, and that is how it is in person. And on screen, same is true with our noise floor. It is our reference floor, noise floor, whatever you want to call it. It is really thin as well. The device in general, I forgot to mention, is a small unit. It is about the same size as a small oscope. It's about the same size as my Tektronix 2235. It's small. So on your workbench, if you have a small workbench, this might be very complimentary for it, and not some big monstrous hideous thing. However, personally, I wouldn't mind having one of those monstrous, hideous things. And in time, when I have a monstrous, hideous workbench or laboratory, I will get me a much bigger and powerful device. But for now, I think this will work. One other thing I forgot to mention, two other things actually I forgot to mention about this device at my opening. One, from what I could find, and again, information is extremely limited, this device sold for a base level of $1,000, more with all the options. Speaking of options, let me go ahead and just state this up front, because again, something I forgot to mention at the beginning. I only have one option, and that is the D-Mod option. And we'll come back to that when we're testing the device. This device is labeled GW Instek. However, Tenma sold the same device. And truth be told, this is a rebadged GW Instek. The model here that we're looking at is a model 72-6696. And my viewers in the UK know that Tenma is a local brand. Tenma is I believe the parent company is Farnell, or it's Newark, and Farnell is the brick and mortar. Anyway, one of those. Tenma is a store brand for Farnell, which is again out of the UK. GW Instek, however, is not. That is a Chinesium product. Back to the markers. We'll turn the markers off. You just hit the marker button again and it goes away. Pretty snazzy, right? To turn the marker on, you just hit that, and now we'll turn off our second marker because we don't need it. Earlier when I was talking about the span and the bandwidth button, when you change those, when you manipulate those numbers, it will change how your display looks. For example, let's go to our RBW button, our bandwidth button. And let's go to our span button. And let's turn off our second marker all the way. Go back to our frequency. Or actually, we were on our span. So far in my limited testing, I find span at 200K and our bandwidth at 30K. Seems to be okay. But, you know, it changes wherever you go, because as stated, the natural status of those two, how they change throughout the span, will dictate, and will also automatically change on you anyway. And now to actually, let's try this. We take a signal. This is coming from my BK 4070 alpha, 4070 alpha signal generator. And it right now is pumping out a 1 meg at a minus 10 dB. And now we have a couple of options of trying to find said frequency. So this is perfect if you're working with AM radio right now. If you wanted to look at a wider spectrum, like the whole band and then some, you put your center frequency on 1 meg, and again, push 1 or center, so it puts our marker up there. Then your frequency, and here you have the option of either hitting enter or megahertz. Also, while you're on center, you could also use your control knob here to dial in the frequency. We'll go ahead and hit megahertz. And there is our signal. We're at 0 dBm attenuation, and we could see our noise floor and some signals down here. Probably going to be some harmonics. So if we want to know exactly what frequency that is, you simply push shift and then hit your marker button, because we're hitting the blue, which is peak to marker, and now it's telling us 996K at negative 24.3 dBm. Now, what I have found in my testing, and I do not know if this is natural for spectrum analyzers to test this way. Like I said, I only have the 2, and I don't play with them that often to know, and I haven't watched too many videos to know if this is common or not. I find that the wider this display is, or the narrower this display is, it can change your resulting frequency by a couple of hertz to maybe being right on. So for people who have a real spectrum analyzer and have an RF spectrum analyzer and have experience with this, if you could fill me in on that, I would definitely appreciate it. Let me know if that's normal activity or not. So let's go ahead and see what we can do here with our span. So I hit the span button. I know it sounds like spam. Alright, so here we have a 0 baseline, 0 hertz, and here we have 2 hertz. So you notice that our marker is off, and now we'll go ahead and we got this little line right here at the top of our waveform. We'll go ahead and push shift peak marker to find out where we're at. And now you see that brought us in a little closer. We're now at 999 kilohertz, negative 23 dBm. Good looking signal. Let's go ahead and change this. And now we're at 5 kilohertz. We'll push our peak again, our center frequency. Unfortunately, this device does not have automatic peak finding. It is all manual, and here you see that our peak did go all the way to the end of the screen. That is normal for this device, and this device now is saying we're at a frequency of 1.024 meg, which could be true. Let's go ahead and push it again, and now we are center of the graticule, and we're at .994 at negative 23 dBm. Change this. Now we're at 10K. Push it again. Slam this back over to the wall, which is we're at the 1049. Push it again, and we're at the same settings as before. 20K. And now it found a high spot over here, 1016. And we keep doing this because it keeps finding all the peaks. It's at this point in time that I wish the knob, you could reach up and change it, right? So there's our .9999999 whatever. So, you know, I was just saying, golly gee whiz, I wish I could change it by the knob, because this is rather tedious. Well, you can. You just push your marker button, go down to your arrow, you select what digit you want to play with, and now you can change that to see the what. Definitely get you closer than having to mash the button. If you want a little bit finer resolution, you change your marker control, and there you go. And see, manually in my eyeball, I'm at center at 1K. Now, that right now is a fallacy. When I got this, my X and Y was off, and I calibrated it, but I know that it's still slightly off. My Y is, so I need to recalibrate that. Also, my marker is sitting at about that. It's not straight on. So when I calibrated it, when I calibrated my markers, I calibrated this for the base to be center. There is a setting on the back that we can calibrate that. I just haven't got around to doing that. Hit our span button, and we go shift marker, and we're back at our 9. We're still on our span. There's our 100. Now we're at 998. There's 200, and now we got some more noise introduced here. Those are probably going to be harmonics. And here we go to 1824, 1.824 megahertz, which should be a harmonic, and then we push this again, and that's 1940. So let's see here, is that the last we could do on our span? Yes, it is. So I think you get the gist of it. So in this setting, I find that if I want to check out the AM radio spectrum, I'm pretty well covered. And change our bandwidth. So there's 4 megs on our bandwidth, 220 kilohertz on our bandwidth, 30K, which is what we're using. I'm sorry, that's, yeah, 30,000. Here's 3K, 3,000. And that is it. And now, on this setting, we're exactly at 1,000. Which is really dumb, because I keep calling this 1,000 when it's actually a million. You know, I'm looking at here, there's no designator, and I just keep seeing the number at face value. So everything I've said up to this point in time, that should have been a meg. Please add that in. My apologies. So we are at 1 meg. Now, if I go up to my signal generator and I change my frequency, let's say I want to go to 2 megs, let's see what happens. It took me completely off the board. So let's go ahead and go to 1.5 megs. Alright, so there I am. And so I go ahead and I hit my shift peak marker until I'm on it. And that's all cool and groovy. But now what if I want that shifted into the center, because now I want to see what's happening over there. You hit your shift and then your delta marker button, because that represents marker center frequency, and there you go. So that is how that works. Okay, so what if we want to do a sweep of the AM radio? So we go to our sweep generator, we punch in 550,000 hertz for our low, we go to our high, and we'll put in 1.8 megahertz, and now we need to change our scan because that's pathetically slow. And you get to see all those neat harmonics in there. So we're at 60,000 milliseconds. Let's go ahead and change this to 6 nanoseconds. A little too fast. Let's change this to 6 seconds. There we go. We'll work with that. And for some reason this generator on this portion always defaults to a plus 10 dBm. So let me go ahead and change that down to 0 dBm. And now we are scanning the AM band. That is really, really neato. Let's go ahead and go back to this frequency real quick. Let's center that. Oops. I hit the wrong button. We center that. To use your delta markers real quick, push that. Go down there. And we're going to take a reading right here at the base of that elbow. And then we'll go to our top marker. Maybe I'll learn something here. And then we'll take that one. Down to about the base of that elbow. And so it's saying 1.689 delta, and our dBm is kind of all over the place there. So I don't know. I don't know exactly how, where, why I'll be using that, but that is the basis of that. Okay, earlier in this video I've mentioned a few times and alluded we'd get back to it, so here is our getting back to it. I made mention that this has a D mod in it. Alright, so let's say you want to check out broadcast band. We want to go to radio station. I've already got this programmed for the low end of the radio. Let me change my reference level to make it a little more sensitive, which we now see down here. I want to grab a antenna, which I have right here, an AM loop antenna. I'll grab some jumpers, connect my AM antenna to it. Alright, so there is our band. Now we're sitting here looking at radio stations, Find our marker. Okay, so that right here is a radio station. Actually, let me redo this real quick. I want to put my frequency at 1 meg, because then I'm going to get better resolution. There, so now I'm seeing the full gamut of the radio station and spectrum, and then just a little bit more. So as stated, I just hooked up this antenna, and we could check out the direction, how well the antenna works. As you see by me swinging it, I'm able to locate those radio stations, and I can confirm that the frequency on marker 1 is indeed a radio station. So that one looks pretty good there. I'm going to set this down, and now let's check out. Okay, that, yeah. Now they're not, it's not exactly dead on, but I mean it's right there. Yep. 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 And no. Okay, so that is pretty neato, right? So now you could test out directions of your antenna. You can locate where a signal is coming from, stuff like that. You can also take these these loop antennas and see the gain for yourself. Now you've seen that walking across the screen. That's me turning this control, but you see how it reacts with the signal. See? So there's our signal that we're currently monitoring, and by adjusting the control, that improved our gain on the signal. So it's really cool for testing things like this. That's cool, huh? All right, now earlier I made, now let's say you just want to test this and not that. Well, simply remove that. Grab your cable, plug it in, move this out of the way so you know there's going to be no influence by that. In the back of this, we have a hole so you can plug it in directly to your radio, and there you go. Turn the knob. And look at that. So that is cool. But now you're saying, Jack, that is awesome. Too bad there wasn't a way to listen to that. Well, there is. As I stated, one of the options that's not in the book but is in the machine is D-Mod. And that is what this headphone jack and this volume control is all about. And the way we access that is you push shift and then center, which is your D-Mod. That changes this to more of an O scope or FFT kind of, I don't know, that thing. It does some things up here, automatically changes your frequency. So now you're on 1 meg, you can't look at a whole span. And it turns off your span and turns off your bandwidth. You have no control over those. Here it's asking, what's our demodulation type? Well, we have the options of off, wide, medium, narrow, or AM. And for AM radio, we will select, I don't know what, AM radio. Now, as you see, we do have a frequency radio station here. Let's go ahead and turn this up. Now you probably can't hear that too well. There is a small speaker inside. Volume control, gain control is all the way up. Now just outside a shot here, I have a amplified speaker, a vintage Radio Shack amplified speaker. We'll turn the volume down. We'll take our plug it into the ear hole. That energizes. Now we are off frequency just a little bit. The audio on this is really not the greatest, but it gets the job done.
Se complica, pero ya tengo aquí 30 años. Sí. Por eso es sumamente crucial hacer un reporte a la
verme llorar, hacerme preguntas, yo.
Don't want to get a copyright strike on that. I have in the past. One thing to note about this is the stronger the signal, the higher this goes. So back to this, let's go ahead and tune for that frequency. And there you go. So now I need to stop saying, and there you go. There you can see that the frequency, the signal did increase. Our antenna is working. Audio is still kind of iffy, but it works. Kind of cool. Now this does cover FM radio, not a problem. As we saw, we had those options, mode types, and we could definitely put it on FM radio. I don't think this hoop is going to work too swell on that, but let's go ahead and let's see what happens. Let's turn up our volume. Oops, let's hit a button that makes it change. And so here we're on AM. I'm impressed this is working. Didn't change the gain or the level, but let's go ahead and change our mode type. For that we go Shift D mod. And here we're in narrow. And now we'll go into medium. And now into wide. And that's crappy music. Anybody can agree to that. So there you go. So now you can definitely DX with your spectrum analyzer. The first night I got this and set it up and played with it, I have a wire, about a 6-foot wire, running up to my overhead camera, just kind of looped up there, nothing major. I use that for an indoor antenna because at the moment I do not have any form of an external antenna, but I do plan on achieving that hopefully this summer. However, moral of the story is I went to the shortwave bands and I did receive a shortwave radio on it. It was kind of cool. I don't remember the frequency, but I think it was 9.870 or 9.780 or somewhere in that spectrum. It was just below 10 meg. I was trying to see if I can get WWV, which I did not. Okay, in this next shot, we're going to put this old-timey signal generator connected up to it. That is a RCA something or another. It's an RCA signal generator. Don't know what the model number is right off the top of my head. Don't see it. Either way, let's go ahead and move forth. We're going to take a signal, plug it in, turn the gain down a little bit. Not sure what frequency we're at, so let's go ahead and plug this into the frequency counter. Probably should have did that first so I knew exactly where I were. Okay, I'm at 90,000 hertz, which I believe is the bottom of the spectrum I've been able to get out of this. So let's go ahead and plug this back into here. And the way how I achieved getting that low, because if you try to push the buttons, they will not let you go that low. The way I was able to achieve to get that low was by manipulating our arrows up here. And okay, we're at 1 meg and we're trying to get down to 90. So now I got to come over here and turn this down, and we're at 980, 700, 500, 200, 190, 130. So right now we are below manufacturer's specs. Specs is 150. We are at 130, and let's push our peak marker, and it does indeed say 90. Now let's go ahead and continue on moving this lower, again just by manipulating these buttons. Whoops. We're at 10. I think 10 is the lowest we can go. Yeah, that's as low as we can go. So that is kind of cool. Now let's move up to 90. And now you see how our numbers have changed. And we should be able to hit 90, and yes, we can confirm we are indeed at 90. On this generator, that's as low as it'll go. I'm sure if I punched in the other one, we could try it, but we see that 10 is probably the lowest it'll go. So in that stance, I'm very happy that it does go lower than what it does read. And while I've got it connected to this old-timey signal generator, this particular generator sports a crystal checker, and so we're going to we've got one plugged in right now, an old military 5.555 megahertz. And let's go ahead and turn off the internal VFO on that, and it'll go straight to our crystal. There's our crystal. Let's go ahead and hit shift marker. It gives us 5.556. Let's center that. And to prove that it is indeed this crystal and not a fluke, we just simply unplug it and the signal goes away. Plug it back in, and there you go. The highest I've been able to find that crystal reader reads is over 40 megahertz, which is very impressive, and that is on fundamentals. Tangent, I know. that thing is very, very impressive. That reads higher than my Sencor FC45 frequency counter with its built-in crystal control. So that is definitely going to stay in my collection, if nothing else but for that alone. There will be a future video on that device. We will rebuild that when we get that far. So please look for that. To confirm also that that is indeed our frequency that we want, we just simply unplug this, plug it into a frequency counter, which we're using this really nice Fluke 1950 Alpha 50 meg frequency counter. I have not demoed this in any video yet, and again, look for it in its future video. So now we need to change this. And did I unplug the wrong item? Or not plug this in? Okay, apologize about that. Technical note. I had to turn up the RF power on that to excite this. And so here you see we are indeed reading our 5.555 megahertz, and that's on this counter where it's shown, and I do believe this frequency counter is spot on. And here's that crystal we were just testing. What an awesome crystal. In a future video or a past video, depending on when I've uploaded it, we'll visit these. Video's already done, in the can. Just need to edit it and upload it. Okay, with all that said and done, it is now time to turn all of this off and follow through with the rest of the video. So let's go ahead and do just that. We'll kill all of this. Kill all my generators, which you'll hear all the noise disappear. Give me just one moment, and we'll come right back and we'll look at the rest of the body, and then we'll open it up and we'll conclude the video. Okay, I've got everything put up, workbench cleaned up a little bit, not too much, but a little bit, enough to move about. I went ahead and took the liberties to remove the screws in order to save a little bit of time. You've got 3 screws per side and then 2 on top. One of the 2 things that I hope to achieve with the next step of showing you around the rest of it, but once we pull the top off and get inside, I need to remove this handle, as I stated in the opening. Because these teeth, as you see, are all broke off. Well, not all broke off, but all broken. I'm sure it had some damage, or it was already that way when I got it, and then when I pulled it out of the box, a bunch of them broke off, and in fact it only looks like there's probably about 4 on this one. Okay, maybe not anymore, but you see now it's stuck. Oh, well, some more just broke off, and that side came completely off. And the center just popped off in that. So if that don't come off easily, I'll just break it off. The last few teeth are not going to go out with a fight, apparently. Oh. Well, those. Well, look at that. That dumb thing's locking and no teeth on it. Okay. Well, maybe I might leave it on. We'll see. Yeah. I don't know. We'll see. Anyway, enough of that. Grab it gently. Here on the rear, we have our AC mains input, and it is changeable for 120 and 220 and a couple other voltages I can't see very well at the moment. Here's our RS-232 input. That's how we control it with our external software. We have a 10 megahertz port if we had the option. That's where that would be. Here's our option sticker, and you see we just have the demodulator noted. Down here we have 3 controls. One is for our trace. One is for frequency alignment. And the other one's for LCD contrast. So trace rotation, frequency, and LCD contrast. And then here we have a small little muffin fan. All right, the moment we've all been waiting for, well, I have anyway. Let's take her top off. Check out her giblets. Now, this is the first time seeing it with you guys, so okay, so we do have some teeth remaining on that one. And 2 on that one with looks like a plastic screw where that one's completely broke off. So I guess in a nutshell it would work. I'll have to see if I can find another handle from something else or one of these and replacement. Anyway, interesting. So we got our big transformer here. We got a daughter board here. And that's one solid board. And then we got the big motherboard down below. And then over here is our speaker is a little dinky thing back here. Taiwan. Looks like it says 0.57 amp or 0.057 amp. 8 ohm, 0.5 watts. Alright, so now we can see a little bit easier, or at least in here to some degree, what's happening. Here we have the daughter board, and then which is on standoffs. The motherboard is just right below it. The big transformer. This is our R232 connection. It's our CRT, and this is a Toshiba. And down here we have our power supply. And if you could see this right here, probably not, but right there where my pointer is going, that is the massive speaker. And one thing interesting about that speaker is on the other side is the our serial number sticker. It's a hard surface, and no vent holes for the speaker to breathe out so you could hear the sound. So it's what I'm trying to say in 8,000 words or less. That speaker's muffled. What's interesting, fun, and exciting is right here they put the fuse right underneath the CRT, right next to the high voltage box. And it's really not at a spot that, I mean, I guess you could dig it out, but would have been nicer if they would have moved it somewhere else, a little more safer, a little more secure. Doing a quick visual of the power supply. Visually, the capacitors do not look bulbous. Of course, I know that doesn't mean anything, but visually they look good. We have this big hole right here. I'm not sure if that's where the tracking generator would mount. If it did, there's only 2 physical connections here, and I would imagine the rest would be like this board, where it's mounted on through these plastic standoffs. We have a little push button here with no silk screening. Here we have a clock that is a 12 megahertz clock. Of course, I just said that, so that don't make sense, right? But then again, I never claimed to. Right here we have this chip. This is made by Excellence Spartan. And that's all I can tell you about that. A couple of spots on the board. We do have little adjusters. Got 2 right here, 1 there, 1 here, 1 there. Not sure what they do, but I'm thinking maybe we should, adjust them, see what happens. I'm thinking I want to take this board off because right underneath, right here, this section, we have some RF modules. So I'm thinking maybe that's where our 10 meg mounts or has to deal with our reference. So I want to look at that. With the speaker right here, make it very easy for me to just tap on here and mount a 3.5 millimeter jack back there for an external speaker. So I probably will do that. But first, let me bump you in a little bit so you could see here. Alright, in this shot here, you could definitely see where the fuse is at right there. And right next to the high voltage box. And here in this shot, you can see that Spartan chip and the crystal, which it is 24. Okay. For some reason I thought I said 12. Maybe I did. I don't know. And you also take note of the all the SMD components in here as well. That I wasn't expecting. I don't know what I was thinking, what I was expecting. Probably more through holes, but there definitely are a lot of SMD. Well, I can't really get you in with this camera to every part of the board, but here's another section somewhere. A lot of little tiny SMD. Alright, have the board pulled apart and pulled out of there. Let's flip it over. Now look at that. Our RF. That's what that is. And so there we have a date on the board and manufacturer, build, and part. Well, I could show you the board a little bit better now. So, and here's that side. I'm looking at my monitor and it's backwards. Alright, so looking at this on the board, this goes to our 10 megahertz on the board. And what's interesting is right here we have, says our third local oscillator, and then right here we have our second local oscillator, and then right here our first local oscillator. And here's a tight shot close up of our first local oscillator. Now, I'm unable to source a service manual for this device. If by chance you know where I could get one for free or for a fee, please leave it in the comments. I would greatly appreciate that. I made mention in the beginning of the video and I forgot to circle back around to it, so let me go ahead and do just that. The owner's manual, user's manual for this device, as stated, is only 35 pages. It has a lot to be desired. It's really weak. It does not go into any technical mumbo jumbo as far as whether the local oscillator should be locked or should not be locked. It gives you no pertinent information. It's really weak. You can find that on the internet because, well, after all, that's where I found it, was on the internet. Here is a close-up of the second local oscillator. Wonder if those are SMA connectors. Yes, those are SMA connectors. Alrighty, so how can I fire this board up safely? Because what I would like to do, if all possible, is fire it up and test these ports to see what kind of frequency I get on them. Well, I went ahead and tried sampling from the ports. Local oscillator number 3 was the only one that was a SMA connector that I was able to adapt over, port over into my O-scope as well as my freak counter, and all I'm getting out of there is just a 60 cycle hum. So that is DOA. Of course, I have not tried going in all aspects of the machine to see if it did anything different, if it needed to be activated some form or fashion. I also have the 10 megahertz. Why are you not seeing it in your screen? I don't have that plugged in. I ended up having to plug everything into the board. Without the board plugged in and without all that stuff in there, it powered on, but I had no display either on the CRT or on the LED screen. And here you can see a little flashing LED. It goes to our crystal oscillator. Okay, well, I think we're going to bring this video to an end. It was a rather lengthy video, I do agree, but I think it was well worth it considering there's not another video that is this in-depth and this thorough as mine, packed full of a lot of useful meat, hopefully. So that will do it for us here on Test Gear Tuesday. I will reassemble this and I will get this thing in line, and I'm very much looking forward in playing with it. So again, thank you for hanging on as long as you did. I appreciate it. And we will catch you in the next Test Gear Tuesday. Hasta mañana. See ya.